Now we start working on web work problems from section 2-1 derivatives. Problem 1. For me, the question says the tangent line to this curve at this point passes through the point this. Question is to compute the following: f at 3 and f prime at 3. So I have drawn a picture, a possible picture. Okay. So I have some curve, all right. The tangent line to this curve. So at this point, 3, -2. That means 3, -2 is a point on my curve and I have a tangent line. Now it passes through the point -10, -3. Okay. So this is another point on my curve, or it doesn't even have to be on my curve. Okay. That point could very well be somewhere else. Looks like, there you go, somewhere like that. Okay, but it's not necessary that the point be on the curve, the second point be on the curve, but the first point is on the curve. So what does that mean? The first point is on the curve means when x is 3, y coordinate is -2, but y coordinate is f of the x coordinate. So f of 3 has to be -2. Okay. Now this tangent line passes through this point and this point, right? So what is the slope? Slope is y2 minus y1 over x2 minus x1. Slope y2 minus y1 over x2 minus x1. Okay, that's what we are doing. So notice I don't have to calculate it all. This is web work. I can simply write numerator over denominator and fill in each piece. What goes downstairs, right? I should have 3 plus 10. What goes upstairs? -2 plus 3. Okay. Mind you, if you use calculator, you will most likely be giving me an approximation. That approximation web work might not accept. So it's best to leave the expression as it is. Okay, next problem. Let fx be this function. Slope of the tangent line to the graph fx at this point is what? Well, derivative or the slope of the tangent line is given by f prime, right? So for 10 minus x squared, what is f prime? So f prime by definition is limit h approaching 0, f of a plus h minus fa the whole over h. Now f is 10 minus x squared. So wherever I see x, I have to replace it by a plus h. Remember, this minus and a square requires me to put a plus h in parentheses. Minus f of a. F of a is 10 minus a squared. Notice parenthesis because of that subtraction. The whole over h. Open this. Remember, there's a subtraction outside, so I maintain the parentheses. A squared plus 2ah plus h squared. Minus, opening the parenthesis gets me -10 positive a squared, the whole over h. Now I will open this parenthesis. So 10 minus a squared minus 2ah minus h squared minus 10 plus a squared. So things cancel. You see, 10 cancels, a squared cancels. Only the h terms survive. Get h common. Minus 2a minus h over h. These two h's go away. You're left with just this factor, -2a minus h, and I'm letting limit h approach 0. So that's -2a. So all of this was derivative at some a, you see. So if that's derivative at some number a, the question is find the slope of the tangent to the graph of this at the point -2, 6. So slope of the tangent is, remember, derivative at the x coordinate. So you are going to plug in -2 in your formula here for the derivative. So that gets me slope is 4. Okay, you have slope 4, so m is 4. All right, you want to find the y coordinate, not y-intercept of the tangent line. Well, tangent line, you have slope, you have your point given to you, you see. So what is the slope intercept, what is the equation of the tangent line? Well, y minus y coordinate equals slope times slope, you see, remember, x minus x coordinate. That is called the point slope form. Okay, point slope form is used when you have point, and you have slope. So you got the point slope form. Now simplify. Y minus 6 is 4 times x plus 2. Simplify further. 4x plus 8. Move that -6 to the other side. That becomes positive. 8 plus 6 is 14. So slope is 4. We already knew that. Y-intercept is 14. Okay. All right. X cube minus 5x plus 1. Find the derivative at 3. And use that to find the equation of the tangent line at 3, 13. Always remember to plug in your x coordinate. 3 cubed, 27, minus 15 is 12 plus 1, 13. Okay, so no problem. That point is very much on this curve. So, same procedure. You want to find the derivative. First find derivative at a using your derivative formula. Okay, definition rather. This is my x. I want to replace it by a plus h. So a plus h power 3 minus 5, a plus h plus 1 minus parenthesis. Don't forget parentheses. So this opens up a cubed plus 3a squared h plus 3ah squared plus h cubed. That's the expansion minus 5a minus 5h plus 1 minus a cubed plus 5a minus 1. The whole over h. Simplify. Look, a squared goes away, 1 goes away, 5a goes away. Only h terms survive. Get h common, right? Once you get h common, h's cancel. Whatever is left, you are taking limit as h approaches 0. As h approaches 0, this goes to 0, this goes to 0. All I'm left with is 3a squared minus 5. Okay. Now that was f of f prime at a. You want the derivative at 3. So plug in 3. 3 squared minus 5. So that's 27 minus 5. It is 22. Okay. Now use that to find equation of the tangent line. Well, you have point, you have slope. Y minus y coordinate is slope, x minus x coordinate. Simplify. Y minus 13 is 22x minus 66. Move the negative 13 to the other side. Becomes positive 13. This is equation of the slope of the tangent line in the slope-intercept form. So that's what they are asking for. Y equals, you see. So y equals. So this is what I'm going to put in. 22x minus 53. All right. So next video will cover, start from problem 4.